So, today, I want to talk to you about 73,939,133. Do you know why this number is special? It's because watch what happens when I write it down. 7, that's prime. 73, that's prime. 739, that's prime. 7,393, that's prime. 73,939 is prime. 739,391 is prime. 7,393,913 is prime. And finally, 73,939,133 is prime. And that is as far as it goes. So, you could just write the number down, and all the numbers formed will be prime numbers. These are called right truncatable prime numbers, and I discussed left ones in a video I made like 4 or 5 months ago. I made it in the end of March, and I just wanted to show you what these numbers do. The second largest is 59,393,339. This is the second largest one that does this. You can write it down and all the numbers form will be prime. And that one's in second place. We also got 29,399,999. And you can do the same thing for that one. And we even got 739,393. These two kind of look cool. They're like cool looking numbers that contain you get a string of 39393 after the 7 here, and then you get a bunch of 9s here. We also got 23,333, and it only contains the digits 2 and 3, both being prime numbers as well. And now that we've discussed both left and right truncatable prime numbers, how about we discuss ones that do them both at the same time? Well, the largest one out of these is 739,397. They're called two-sided primes. And if you were to take away the digits from either side, it will remain prime. Like this is prime, this is prime, this is prime, this is prime, and so is that. You can also go from the other side, like I said before. This is prime, 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 and then this is prime. And those are pretty cool. But what if you were to delete the digits in any order from any position? Well, those numbers don't really exist. The only ones we found, the only ones are 23, 37, 53, and 73. You can remove the digits in any order and it will remain a prime number. Like, let's take 37, for example. That's a prime number. So is 7. And so is 3. Well, we've found none of them that are, like, have greater than 2 digits. If you wanted to allow 1 to be a prime number, you could have 137 and 317 as one of them. You can make those on the list, like take away the 3 from here. 17 is a prime number. 37 is a prime number. Remove 2 digits. 3 is a prime number. And then 1 is not a prime number, but we'll count it as 1 because it still has less than 3 factors and is not composite. You can do the same thing for 317. Well, 373 kind of works, but you can just assume that all the digits have to be connected in order for it to remain prime. Like these 2 digits are not connected, and 33 is not a prime number, so that one does not really count, but we could include it if you'd like, but yeah, like if we allow that rule. But there's other prime numbers that have similar things with the digits. Like, there is one number that I like, and that is 19,937. So, this number is called a circular prime number. And what is a circular prime number? Well, you have to go from any number, like any digit, and rotate it from that position. Like for example, let's start from the 9 and go back to here. 93,719 is prime, and so is 71,993. And so is 99,371. And finally, 37,199. That one is also prime. All of these are prime, and they're rotations of that number. We also found a couple more of them, like 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. But that one's boring because you can go from any number and it will remain the same. But it's not a boring number, but it's boring in the context of circular primes. So we're gonna not count these numbers. They're called rep units because they contain only the digit 1. But not including the rep units, the largest circular prime we found is 999,331. You can rotate this number from any position and will remain a prime number, like 933,199 is prime. And we found none of those. Like, there's a very limited supply of those because we cannot have 0, 4, 6, or 8 be a digit, because, like, if you have something like 4, 4, 6, 3, this is a prime number, but if you go from any position, like, start from the 3 and go around, like, you'd have 3, 4, 4, 6. Womp womp. That is not a prime number, it's even. You also can't have any of those like 0 or 8. The numbers 2 and 5 are also not allowed because if you rotate them from there, it will be divisible by those two numbers. Like if you go from the one I was talking about, like 59,393,339, the second largest right truncatable prime number, you can go around from this digit, this digit, you'd have 9393395. Womp womp, that's divisible by 5. You can't have that. This is why we only need to have the digits 1, 3, 7, and 9 to do it. And this number fits the criteria, and so does this. But if you were to check out other numbers where you can not just rotate the digits, you can just put them in any order. Like, there's other numbers that I've found that do this, those being, we also got 337 being one of them, because you can actually rotate the digits. Like, you can put them in any order, like 373, that's a prime number, and we just move this 7 over here. And so is 733. You can just reverse the number and do that. Those are called permutable primes, and there is a very limited supply of those as well, because they're extremely rare numbers. And I think the largest one we found out of those is 991. I think that's the largest one that does that. And anyway, that's it I can say for those weird-looking prime numbers where you mess around with the digits. These are pretty rare numbers, and there's finitely many of these. So, that's it. Bye!